Hello and welcome to Leaders Up Close. It's a program of the Engineering Leadership and Innovation Institute here at UCF. We thank Duke Energy for supporting the program. Today we're real proud to have one of our alumni back to share his story. He's Jason Dunn. He is the co-founder and chief technologist of Made in Space. And he's going to share his story with us today. And it's all started here at UCF, which is kind of cool. So anyways, please welcome Jason Dunn.
Thanks, sir. All right. I got to first just thank Tim and Robin and everybody else for setting this up. It's really exciting to be here. I was just telling these guys that I've been kind of speaking a lot this year, and I'll go into why. Mostly because Made in Space was really in stealth mode up until February or so we were not talking, and then I started to get to go out and talk. And so I've been around the world speaking. I was in Brussels a few weeks ago speaking to 2,000 people, and this is by far the most exciting talk I get to give. And I don't say that everywhere I go. But you'll see, actually, it was a complete surprise that we're in this room. You'll see, like, my first slide is a picture of the atrium. So I want to first start by asking, well, first of all, I was trying to change this slide and add one more thing, hashtag ELI2 for Twitter. I learned that we're not trending on Twitter yet. So who's tweeting in their lives? A few of you? All right, so tweet, hashtag, say this is awesome, and put that up there. I think we'll start that today. Okay, so a couple more shows of hands. Who is excited or interested in being an entrepreneur? Good, a lot of people. Okay, that's what I expected. What about, and we're all engineers? Mostly everybody's here engineers. Let's see, like, show of hands for the different groups. Mechanical, that's a lot. Aero? Woo! All right. Civil, got some civils. Electrical? Nice, cool. How about, is there computer science also? Yeah? Okay. What else is there? Like, industrial, right? Of course, industrial. Awesome. Am I forgetting any? So you have a good spectrum here. Nice. Okay. Cool. Well, the good news is entrepreneurship is for anyone, not even just engineers. And hopefully what I can get across today is the story I've gone through really since I was here at school, and how I decided I wanted to be an entrepreneur and what that means, and all the things I've done since kind of 2008, 2009 when I started that path, and how it's got me to where I am today. And then I want to talk about this idea, the power of exponential thinking. And it's a pretty new concept. Actually, who even knows what that means, exponential thinking? Awesome, perfect, nobody. All right, so you're all, hopefully by the end of this, you guys will be all pumped up about what this means. And I should actually, so this is kind of a filler slide, but yeah, I want to talk to you guys about that story, and then hopefully convince you that you guys all have the power to change the world. And that's really the point of this, is that it used to be big corporations that had the power to change the world, and now those corporations are getting completely disrupted. They're bankrupting overnight, and the people taking over are the people your age, small groups of 23-year-olds in a basement or a garage creating some new company or some new app or something that completely destroys industries. And that really is the backbone to what exponential thinking and what that really provides. So 3 points I want to go through today. And there's a lot more to it than just these 3 points, but I think these are kind of capture the message I want you guys to walk away with. And the first one is that today humanity is advancing at an exponential rate in technology. Technologies are changing very, very quickly, and it's really important to understand how technologies are changing, not just to be an entrepreneur, not just to create new products, but because that can completely change what happens in your life. And the second point, it goes into that, is you really need to understand how to not let this technological change leapfrog you while you're in school. There are entire industries that will be gone before you graduate. And it's important to know if the industry you want to work in is actually going to be gone before you graduate. I think you would all agree. So That's really important. And the last is, it's really good to understand how to anticipate this technological change so that you can leverage that and do something really impactful, change the world. It's not just about creating apps. I live in Silicon Valley, where I'm surrounded by people our age who are creating apps, selling them to Googles and Facebooks for billions of dollars. And it's amazing to watch that happen. But at the same time, I feel like it's much more important to spend your time doing something a lot more worthwhile than building an app, maybe using that same ideas, those same mindsets, those same technologies to really, really change humanity, to solve some of the biggest problems humanity has. And that's the cool thing, is that humanity has big problems, and today we all have the power to solve them. And that's something that wasn't around even a decade ago, as easy as it is today. Am I in the way of this? You guys can see this? Okay. So this is where it all started for me, right out there. I can't believe that I get to talk in this room, and I had this slide here. We're like right there. So I put up this slide because I want to kind of tell you guys the story of what happened while I was here and how that got me to even deciding to do anything relevant to what I'm doing now. So it was, I specifically remember 2005, it was the summer of 2005. I was taking one summer class, and I had a lot of free time. And I was walking through the atrium and trying to figure out what to do for like the afternoon. And I saw a sign down where all those little signs are for different clubs. And it was a sign for a club that was building model rockets. And I'm an aerospace engineer, and I was like, all right, this is cool. I'm going to go to the model rocket club because that would be fun. So I go into, it's a room up in Engineering 1, I think, that it's a small conference room with like a space shuttle mural on the wall. I don't know if that's still there, if you guys have seen it. Small little room, it was a small club. And it was really cool. I joined this club thinking that I was in this club that builds model rockets. I didn't think that it was anything more than a model rocket club, because that's what these guys were doing, was trying to build the first hybrid rocket to go suborbital, for the first college group to build a suborbital hybrid rocket, which was a pretty cool idea. We were competing against Embry-Riddle. Embry-Riddle had a project called Icarus, so we created ours called Daedalus, so that we thought it was a funny joke that if their rocket was one that was going to burn up in the sun, we would have the daddy rocket. So it turned out that this club was a lot more than a model rocket club. That I learned like the next year we held the national conference here, and the club's called SEDS. So any SEDS? Oh my gosh. Really? Nobody from SEDS? All right, got to join SEDS. I don't know how well SEDS is doing today, but when I was part of the management group in SEDS, we were inducting 100 people every semester. And it wasn't just engineers, it was across the entire campus. And it was because it actually was a lot more than a model rocket club. And what we learned was, SEDS was actually, it was founded by this guy, Peter Diamandis. Anybody know who he is? A little bit? All right, so this guy, look him up, really, really forward thinker. And he's become a really good mentor of mine. And it all started in SEDS. And I like this quote because this actually is kind of the theme, not just of the talk, but I think it's a quote that I've followed my whole life, which is the best way to predict the future is to create it yourself. And it's totally true. In fact, that's how everything is ever being created, because somebody had an idea for something that didn't exist and they decided to create it. So it turns out SEDS is a lot bigger than a model rocket club. A lot of the most important people in the space industry were students in SEDS, and they've gone on to change a lot of things. And then the people in SEDS went on to create other really important endeavors like International Space University and a lot of different companies in the space industry. So this is where I really got a start. And it was at that first conference that we held here, and probably in this room and some other like classrooms here, where I met people from this commercial space industry. And I had gone to school thinking, I'm going to work for NASA or Lockheed or Boeing, because that's the space industry, and I'm going to build, and I want to build rockets, and I still love building like propulsion and everything like that. But it was at SEDS that I learned that there's a lot more to it, and that the industry was changing, and that there was new doors opening. And it was the first time I heard somebody say you could be an entrepreneur in the space industry, which I thought they were completely crazy. And I walked away thinking they were crazy, and it was years later that I started to warm up to it. So I'm going to go over I think I have a few lessons in this talk that I think are important to go across. This is the first one. The best opportunities in college will happen outside the classroom. And SEDS is the first example. I'll go through a couple more. And it's really important takeaway, because if you're here just to sit in class, you're going to learn a lot. But it's when you get out there and start doing that you'll really not just learn more, but learn what you want to do with your life. So it's really important. Like I said, I wanted to work for NASA, and in a way, I get to work for NASA today, and I'll go into that, which is cool. But so I started with internships, and oh, sorry, I just ruined something. Okay, let's talk about this first. Do you guys know what all these people have in common?
They dropped out.
Yeah, that's true. They did. Well, they're also billionaires. They're billionaires who all dropped out of college. And I'm not here to say drop out of college. I don't think I would be invited back if that was my message. But it's important to realize that the people that you rely on today for all your technology, or a lot of them, they actually didn't even finish college. So college is important. It's important to understand why you're here. But don't let it be a means to an end. Get out there and do more than just sitting in a classroom. That's the point of that slide. So don't drop out of college. Okay. Yeah, I skipped a lot ahead. So this is the first place that I got to do things out of the classroom. I was undergrad and then grad. I had the privilege to work with Dr. Kapat. Are you here, Dr. Kapat? Is he here? No, I thought he was going to be here. Really amazing guy. He was kind of my first mentor. And that's another important lesson, is it's important to have mentors. I've had a lot of what I've done today is because I had the right people guiding me. So find mentors. It's really important. Dr. Kapat was one of them. And I got to work with him out at CATER, the Center for Advanced Turbine Energy Research. And the turbine lab that's off a little ways off of campus behind the observatory, because everything there is really loud. So it's a wind tunnel shop, right? And in the back of CATER, in the back of this building, is this supersonic wind tunnel. And when I got there, it was just sitting there, not being used, completely just in disarray. I learned that it was actually purchased by the physics department back in the 70s, I think. And it used to live in the basement of the physics building, but every time they'd run it, it would set off the fire alarms. So they had to move it off campus. And it's a blowdown tunnel. So there's this huge compressed air tank outside. You fill it up, you open the valve, and it blows the air down the tunnel, and you get like 5 seconds of supersonic flow, Mach 4, something like that. And it's like a 4-inch cross-section, little tiny cross-section area, and you can put like cool little models of airplanes and things in it. So the school bought it as a teaching tool, and they never ever used it for teaching. There was like a couple master's theses were written on it where the students like calibrated the wind tunnel and then did some little things. So I came in, it didn't work, it had been sitting there. Last time it had been run was a few years prior when somebody did their master's thesis on it. So I was a high-speed flow junkie. That was like my favorite classes. And I had never even it was all textbook for me. I never actually played with supersonic flow. And this thing was sitting there, and it wasn't something that Kapat had funded projects on or anything like that, but he let me spend my spare time fixing this tunnel up. And it took a little bit of work to get it going. Most of these gauges didn't even work by the time I got it to work, but I was still able to run the tunnel. And the way you actually visualize the supersonic flow is a thing called Schlerin photography. It's basically a set of mirrors that reflect light through the tunnel, and kind of like, on a hot day when you see that haze above the road, that's different density gradients of air. And there's a way to actually pull out all the density gradients in a supersonic flow, and that's how you can see a shock wave. So I set up that system too. I had no idea how to do optics or anything like that, but this was the first image I got. Actually a really horrible image if you look at what Schlerin photography looks like. But I was super pumped that I got the wind tunnel to work, and I put in this rocket nose cone type object, and you can see the shock wave. Is there a laser pointer? Oh shit. Okay, I'm not going to try to find the laser pointer. So there's a normal shock moving across. You can see these expansion fans off the edge. It's really cool. And from that, you can actually measure how fast the flow is going, all these cool things. So I ended up getting this this tunnel working, and we, at the same time, I was a TA for the measurements class. So if you're mechanical and aero, you know what that is. And I created a whole program for getting the students to go run this tunnel. So we, for the first time since the thing was put in the building in UCF since the 70s, we ran students through it in one semester. Every student in the measurements class got to learn how to run a supersonic tunnel, see what supersonic flow looked like, all that cool stuff. It was really rewarding to me because I thought this was cool myself. So that was like my first lesson of do things outside the classroom. I learned a lot because it wasn't just a textbook of supersonic flow. It was actually creating supersonic flow and looking at it and understanding what it was. And now I love this stuff still today. And actually, I think there's a lot of I definitely learned a lot here that I've transferred over. You know, understanding how a Schlerin photography works. I ended up, I worked for a company for a couple years, ending last year, called Moon Express, and we were building. I was a manager on a project to build a telescope for the moon. So there was stuff that transferred over, just understanding this. All right. So next, I got to go work at NASA. And this is one of my favorite photographs. I got to spend a week crawling around Space Shuttle Discovery and going inside the propulsion module and understanding how every little thing worked inside the engine room of a space shuttle. And I had internships at NASA. It was one of the most incredible experiences of my life. Like I said before, I always thought that NASA is where I would work one day. It was actually while I was out here doing these internships, I started to watch a lot of people get laid off. The shuttle program actually was ending right when I was out there. So I was crawling through Discovery, years before it had its final flight. And that was a real big kind of blow to me. I thought that was my future. At least I thought I was going to go work on Space Shuttle. And then I watched it get retired. I watched thousands of people lose their jobs. And at the same time, it was the people at SED saying, the space industry is changing. There's this thing called commercial space, and you can create a startup. And NASA was saying it. They were saying they want to invest in commercial industry to help keep things going. So I recognized that there was a change, and that if I was going to work for NASA one day, the best way to do it wasn't necessarily to be one of the other engineers there, but to actually go create something that NASA would want and give NASA the value that they really wanted. And that really changed a lot of things. So I had a lot of fun here. And then this is kind of encapsulates that realization I had. And I have a few other friends in California that we all have this mentality that we're the orphans of Atlantis. The idea is there's a lot of our mentors say they were the orphans of Apollo. They grew up watching Apollo, people walking on the moon, and then they thought when they were older they would be living in the Enterprise, going to Alpha Centauri. And they were really upset that didn't happen. And actually, that's why SEDS was created, because those students thought that it was time to get students more excited about space again. So we're the orphans of Atlantis. All of us are. Whether you guys realize it or not, we watched the shuttle, and that was the end of an era. And now it's time for us to figure out how to keep this industry going. And that's really more of my message to the space people. But hopefully by the end of this, you guys are all space nuts like me. So we're orphans of Atlantis. All right, so lesson number 2. It's not so important what you do for a living as what you're living to do. And this is really the big realization I started to have around that time, was that I always had a dream job in mind. I wanted to go work at NASA and be a propulsion engineer. That was it. That was my dream job. And then I started to watch that go away. And I realized, it's not important to have a dream job, it's important to have a dream. If you have an idea what you want to do with your entire life, if you have a life purpose, then everything will start falling in place. It's a lot easier to think that way. So I almost said big, but then I said no, it's gigantic. Set gigantic life goals. Set something that's so wild that people think you're crazy, and that you think you're crazy, and that you don't actually think it'll happen unless you work your ass off for your entire life to make it happen. So I'm going to share with you my crazy life goal, and that's I think that it's completely within the realm of possibility that within our life, our species is multiplanetary. That we're living on other planets, that we're even creating worlds of our own. One of my favorite ideas is living inside of these O'Neill colonies, things that are in a Lagrange point between the Earth and the Moon, and they have their own gravity field, and you can grow plants, and you can have, my dog could live with me in space, that kind of stuff. This is technologically possible. I mean, you guys saw Elysium? It's possible. I don't think it'll be a dystopia like that, but I want this to happen, and it can happen, and it's just a matter of if you want this to be the future, then make it happen. So I believe it would be one of the most important thing ever that humanity has done if we actually became multiplanetary, if we backed up humanity. I mean, think about it, we're completely locked on the surface of this planet. There are so many ways that life as we know it could just end in an instant. It's important to think about the fact that we have the power to fix that and to make sure that that doesn't happen. So this is my crazy life goal. Everything I do has been based on, will it get us a step closer towards this happening? And as long as I'm working on that for my life, I'll be happy. I hope that this happens in my lifetime, but I know that at least I can help move us closer to that point. So set big goals. And through that, I started going after those ideas. This is the first kind of real endeavor I took after realizing how I wanted to impact the space industry and realizing what my life goal was. I co-founded a company in 2008 called Earthrise Space. Do you guys know what this is? A little bit? You know everything. Were you an aerospace engineer?
Yeah.
Okay, good. So Earthrise, really cool story. These guys, the company's out here. It was founded by a few of us. I was a grad student at the time, and there's a thing called the Google Lunar X Prize. Have you guys heard of it? So it's a cash purse, the first privately funded team to put a robot on the moon, take some pictures, send back video and images to Earth, gets $20 million. And I had heard about the prize. Thought it was a little crazy, which is good, because crazy ideas are what I like. But then I heard that this guy up here in the middle, Ruben Nunez, was trying to go after it. He wanted to start a team. Somebody showed me a picture of the first rover they had designed. I thought this was crap. So I went to his first meeting, and we sat down. We kind of back of the envelope calculations from what we understood from all the courses we took, figured out that you could probably actually do this mission within somewhere close to that prize range, which is cool if you could actually break even. So we said, let's go for it. We looked at all the other teams. All the other teams were actually companies. And we're like, OK, well, I guess we have to start a company if we want to do this. So we ended up that day not just creating a team, but creating a company. And we called it Earthrise Space. And the idea was that it's a nonprofit that gets any student who wants to work on real space missions hands-on access to do it. Not just plugging Excel spreadsheets for an engineer who's doing a space mission, but actually hands-on building a space mission and flying it. And our first mission would be this mission to go to the moon. So we started to build rovers, and here's a picture of the rover. And Earthrise has been really successful. They're in the research park right now with a big team of people. And so I definitely urge you guys to go check out what they're doing. But that was kind of me just jumping in head first into entrepreneurship. I had no idea what I was doing. And it was, for me, it's always been a lot of learn by doing, and also having these mentors that could help me. So Earthrise Space was the first one, and I worked. There's an incredible story. I could spend the whole time just talking about that. So then we went into. I went to California in 2010, really trying to understand how to be an entrepreneur, how to really make a huge change in the space industry, and we looked at this. Me and my co-founders, I ended up finding there, we looked at all the problems in the space industry, realized that launch is really the biggest issue. Everything we design for space has to fit inside a launch vehicle, has to survive the loads and the G-forces and the frequencies to launch. We design everything for launch. So we said, that has got to change. And the supply chain to space is a problem. We build rockets that have to be taken on barges across oceans. We have to put them on trains to the launch pad. When you finally get it blasting into space, it takes this enormous amount of energy to put that little payload on the top into space. The Apollo astronauts had to travel 10 times the speed of a rifle bullet just to get to the moon. In fact, anything we've ever sent outside of Earth's gravity wells had to travel that fast, 10 times the speed of a rifle bullet, which is crazy if you think about it. And the cost perspective on that is a liter of water in space costs about $10,000. And that price hasn't changed really over the course of time because we are completely dependent on chemical rockets, and there's a physical limit, and that's just how things are. And if the purpose of a supply chain is to move goods from A to B, you could improve upon that supply chain by either moving the goods quicker or just reducing the distance. And we've done a lot trying to get things quicker to space, but hardly anything in terms of reducing the distance to space. So that's what we started a company to do. It's called Made in Space, and the idea is that you don't actually launch things to space, you build things there. And it would get around that fundamental bottleneck with the space industry that we have today. So, so we set off on that goal. The way we want to do it is not incredibly surprising. It's a new technology. It's exponential thinking that I'm about to go into. It's been called the third industrial revolution. It's 3D printing. So we've been building 3D printers for space. We chose to put a printer on the space station as our first goal because we feel like, well, first of all, that's where the only astronauts are in space today. So if we can give them the benefits of 3D printing and manufacturing, it reduces their dependency, and it also opens the doors. It allows any of us in this room to get hardware to space simply by emailing it. So think about that, emailing hardware to space. It's crazy, and that actually is happening next year because next year we'll have the printer up. And the way we actually got, from idea 2010 to now, we're actually building flight hardware for the space station, and it's me and a team pretty much as young as I am. So how we did that so quick and got NASA on board is an incredible story. A lot of it started in zero gravity. This is where we initially got NASA thinking about this idea. We got some microgravity flights in 2011. We were flying our 3D printing experiments in zero gravity. I was having a ton of fun. It's, if you ever get a chance, it's the coolest thing you'll ever do. Hands down, the coolest thing you'll ever do. My favorite thing is to do this, to go upside down and realize that there really is no down in zero gravity. Whichever way your feet are facing feels like down. So you can look down, first of all, your feet are on the ceiling of an airplane, which is weird. And then you look down the plane and everybody else looks like they're upside down. So, so we did a lot of experiments, and it allowed us to iterate very quickly. We took commercial 3D printers, ran them, and found out that none of them were working. Our hope was that we were just going to take a commercial 3D printer and put it on the space station, and that we'd get to that milestone of ISS printing very quickly, and we learned that it didn't work. And we had to do a lot of iteration to make it work. So my next lesson is that failure is an option, but persistence to the point of success is mandatory. And that's definitely a value within Made in Space, that the idea of allowing yourself to fail, iterating very quickly, like don't just sit around and try to design the best 3D printer for space ever. Start with what you have, see what happens, and then iterate. And the quicker you can iterate, the quicker you can actually find your failure points, the quicker you'll be successful. As long as you're persistent and make sure that success happens. Don't lose all your hope. If everything works the first time, you aren't taking on hard enough challenges. I think that's really true. We got to be thinking about doing things that aren't going to work right away. Do things that half the people say are crazy and the other half say, that might work. That's really what we should be going after. All right, so and that led us to where we are today. We're building flight unit 3D printers, the first of its kind. No 3D printer has ever been designed with these requirements in mind. Got really cool clean room lab and stuff in California, and a really awesome team to do that. So one of the side effects, and I'm not doing this to brag, but we've got a lot of press lately. This is just from like the past probably 5 months. Millions of media impressions, thousands of different places. We've had press in print, online, TV, things like that. And what I'm trying to bring up here is a question you should already be asking, is like how the heck how did we do this? I mean, the odds are against a small young group of entrepreneurs trying to build a Silicon Valley style startup to compete in the space industry. How did we do it? We're young. We started with just the money in our pockets and went straight to our customer, which is NASA, and we're competing against industry giants. So how did we do it? And the answer is exponential thinking. We built our company on exponential thinking. So what is exponential thinking? All right, so for me it started here. I had no idea what it was either. I went to a thing called Singularity University. Anybody heard of this one? All right, a few people. So you guys all want to go here. This is this crazy place, and it's actually at NASA Ames Research Center in Silicon Valley, the heart of Silicon Valley. They bring in 80 students every summer, most brilliant people. It's really competitive to get into. And all you do for 10 weeks is you learn about the world's biggest problems. You learn about really incredible technology that is advancing at an exponential rate. And then you figure out in groups how to take a technology and solve a problem in a way that no one's thought about. Take a technology to solve a problem that we haven't tried before. So it's about solving huge, huge, huge problems. In fact, the goal of the project is to create a company or an idea that could impact 1 billion people in 10 years. That's like super crazy. And that's actually where Made in Space came out of. That's where I found my co-founders. And it was there that we really thought about the problems with the space industry and then how do you take an exponential technology like 3D printing. So let's talk about what that actually means. So exponential technologies are something that all are part of this idea. Have you guys heard of Moore's Law a little bit? I'm sure the computer science guys definitely have. So Gordon Moore realized that the rate at which computational speed is increasing is very, very predictable. It's why you buy a cell phone and then the next week there's a cell phone that's like twice as fast. And that didn't happen, obviously that wasn't happening 5 years ago or 10 years ago, because that's happening on this exponential curve. And what's interesting is so this is the cost per calculations per second for $1,000. So like how powerful your laptop is something that we can predict, right? So and it all goes to integrated circuits, transistors, back to vacuum tubes, relays, all the way back to like punch cards. Completely predictable. What's really incredible, look at this. It hasn't changed during times of war, during times of peace, during times of prosperity. It's completely on a predictable curve. And the other interesting thing is it's logarithmic. So notice that it's an exponential curve on a logarithmic scale. That means that the rate that this technology is increasing is in fact increasing itself. So technology is accelerating really fast, and the idea is how do you understand that? Because it's only going to get faster, right? So here's another way to look at it, which is really crazy to me, is looking at calculations per second again, but what's the calculations of an insect brain, of a mouse brain, of a human brain, of all the human brains on the planet. Look at this. It's predictable when we're going to have a laptop that can compute at the power of every single human brain on the planet. It's predictable. We know when it's going to happen. In 2040, 2045 time range, your laptop will be that incredible. So what does that mean? Like you guys should all be thinking about what does it mean when you have that technology? When the technology in your pocket is as smart as all of the humans on the planet. That's going to change things. So how does that actually translate outside of computers? A really interesting one is photovoltaics. You can actually track the performance of solar cells. And we know from this prediction when the cost performance of a solar cell reaches grid parity, which means when it's cheaper for an energy company to install a field of solar panels and supply you energy that way rather than burning coal. It's not far away. It's like within the next decade, there's absolutely no reason to burn coal anymore because solar cells will be so much more efficient that makes more sense, economical sense for an energy company. So it's about understanding how this happens. And the reason this is tied to exponential technology is because it's all tied into information technology. The computers are information technology. And as soon as something is what we call information enabled, it falls into Moore's Law. And that's something that photovoltaics are on and a host of other things. 3D printing, AI, robotics. I think I'm going to go into a couple things. But first, it's hard to think exponentially, right? Our brains are hardwired to think linearly. If I said, take 30 steps that way, it's pretty easy to understand 30 steps, I'll probably be at the door. But if I said take 30 steps exponentially, right? 2, 4, 8, 16, 32. It's hard to understand where you are 30 steps later. Do you guys have any idea? Just a guess of how far you would be 30 steps later? Let's throw out a number. 1 gigabyte? Interesting way to think about it. OK, let me give you an idea. You would be able to go to the moon and back twice, and then you would still be able to circumvent the globe about 28 times. So that's the difference of exponential thinking to linear thinking. And the problem is we've always been linear thinkers. That's how our brains work. So you have to start to understand that you have to think differently. That's the point of this. So how is exponential change impacting the world today? Let me go through a couple crazy things. This is a Maasai cattle herdsman in Africa. And they're a nomadic tribe, and they all have cell phones. They all, in this guy's hand, he has more access to more information than the President of the United States did a decade ago. This is incredible. These guys, they're connected wirelessly. Africa is going to completely skip the telephone lines altogether. It's just wireless. They don't need it. They completely leapfrogged an entire industry. And now this tribe is connected. They're doing money transfers on their cell phone. They have bank accounts. It's wild, right? They're being told by the government where to take their cows to get the best food for them to eat. So this is changing. That's incredible, right? This is a picture right down the road from where I live. I live right next to Google. And every single day when I'm driving on the road, I see these things. You guys know what this is? A self-driving car. So every day I drive next to a car that has nobody in the driver's seat. And this is, these cars have logged over 500,000 miles, and they haven't had a single accident. They haven't had a single accident while the car was driving. One time they had an accident when the person in the car took over, and he actually got an accident. So let me see if, we're going to run out of time. I had a video, but we'll run out of time. OK, I got shot. Let's see. Hopefully it works. Yeah. You guys stay after, and I'll show it to you. It's really funny. It's what happens when human beings experience intelligence close to theirs. It's somebody driving in one of the cars. OK, so this is wild. There's cars driving themselves. Robotics is, cars are now information enabled. Think about that. Cars are now going to be increasing in technology on that trend of Moore's law. That's pretty crazy. Florida actually already is passing laws to allow this to be legal on the roads here. And Florida is one of the first to do that. So maybe you'll see this soon. Maybe the taxi taking you downtown so you can go out to a club will drive itself. Robots are doing other things. This is Baxter. It's really cool robot, pretty new. You don't have to program it. You actually move its arms and teach it what to do, and it learns tasks. You put it on an assembly line, and it'll start sorting things just because you actually showed it what to do. 3D printing organs. This is something that's happening, right? This is crazy. We can 3D print organs now. Robotics, again, people that can't walk are now being able to walk. I'm going to go kind of quick because we're running out of time. This is the craziest one, guys. Biology is information enabled. Check out this website, Genome Compiler. You can actually program your own type of DNA, and then they'll send you that DNA. You can it's kind of expensive right now, but you can do that. And it all started because Craig Venter sequenced the human genome, and all of a sudden we had the code of life. So that's wild. This lady is taking DNA and reconstructing what the person looked like. She's taking cigarette butts out of the subway in New York and figuring out what the person looked like just from the DNA, and then 3D printing their faces. All right, so I'll go through this. This is really important. So exponential thinking is disruptive, and that's really what it gets to, is you got to be looking at things disruptive. And I'll skip these things here. You'll have the slides. Disruption seems like it comes out of nowhere, because as people are trying to create revolutionary things, disruption is happening real low down, and then all of a sudden something happens, and the technology spikes, and it completely kills an industry. So the difference between revolutionary and disruptive: a car that can self-park itself, revolutionary, right? You buy a car and now it can parallel park itself. Then Tesla comes along and they build an electric car that if they're successful, will completely kill the automobile industry the way it is today. That's disruptive, and that's what we should be looking for. So what does disruption look like? Do you guys know what the spice trade was for? Yeah? Anybody? Spice trade was for food preservation. We use spices to preserve foods. The guy who disrupted the spice trade was this guy, Frederick Tudor, known as the Ice King, because he decided to go harvest ice out of a lake in Massachusetts and sell people ice. And he was transporting ice down to the tropics where they needed refrigeration. So all of a sudden, everybody in the spice trade, that entire industry went away because the ice trade was created. Completely different stuff. New industries were created. Ice houses were created. New markets. We have these things where people put ice blocks in this little box and kept things cold. There's people delivering ice. Completely new markets were created. And then it was disrupted by this guy, John Gorey, in Florida, who created a refrigerator because the ice was it was melting and it was taking too long to get here. So he created a refrigerator. Completely did away with the ice trade. Completely disrupted. And then once again, we had new markets created, refrigerators. Everything that we know got a lot better because of it. So next lesson, don't just compete in existing markets, anticipate and create new ones. And that's a really important one. I think that's really good. Almost done. So this is where you should be thinking about right now. Is the company that you thought you were going to work at when you graduate about to get disrupted? Great example, Kodak. This guy actually, at Kodak, invented the digital camera in like the 70s. Kodak invented the digital camera. And at 1996, market cap of $28 billion. They had 140,000 employees. And then last year, they were bankrupt. And they went bankrupt because they didn't think this little crummy camera was ever going to be anything, so they didn't invest any effort in making the digital camera happen. And that's what put them out of business, digital cameras. Kodak went out of business because of the invention they created. And then just a couple years ago, a completely different type of photography company came out called Instagram, leapfrogged digital cameras because it's just an app on your smartphone. Company was founded with 13 employees in 2011, and then the same year Kodak went bankrupt. They sold to Facebook for $1 billion. So 13 people just sold a company for $1 billion. So look, these guys were these guys were young. They were like everybody in this room. So there's no reason to think that you can't actually kill an industry giant and make the world a better place with that technology. And real quick, going back to space. Actually, we're out of time. So I'm going to pale blue dot. I love this stuff. Everything we know is here stuck on this planet. We got to fix that. We're reminded by that with asteroids. This is where I think we're going to be one day. I think we're going to live in space, and by doing that, we're going to solve problems here on Earth. And there are a lot of problems to solve, and that's really the point here, is that now more than ever, like, you can do well by doing good for others. And that's an important point to think about. It's not like you can actually do incredibly well by doing good. There's huge problems to solve on this planet. You don't have to go create an app. Spend your time creating a technology that solves hunger or clean water or energy, something like that. So my last thing, my challenge to you is to dare to do crazy things. Find your life purpose and never let somebody stop you from pursuing it. And I'll just end with this Steve Jobs quote, because the ones crazy enough to think they can change the world are the ones who often do. All right, right on time.
Perfect.
Let's do some questions.
I'll get the first one, I'll turn it over.
Okay.
So who stops us from doing the crazy things?
Who stops us from doing it?
Who has ever stopped you from doing something crazy?
There are always going to be people who don't think that it's possible. And there's definitely, I mean, I can definitely think of that happening a lot. I'm kind of in the mindset where once I think it's possible, even if I know it's crazy, I don't let people tell me. Actually, when people tell me I can't do it, that makes me, try harder and do it more. I like this quote, the day before something is truly a breakthrough, it's a crazy idea. And that's, I think that kind of encapsulates it.
So who's going to stop these students from changing the world?
Yeah. Well, somebody said government. I think that's maybe a fair assessment. But I think what it is, it's these industry giants. It's the people, it's the Kodaks out there that they don't want to be disrupted. And instead of working to disrupt themselves, that's the trick, is you need to, things are changing so quick, you have to figure out how to disrupt yourself before somebody else does. And Frederick Tudor, the Ice King, he actually tried to make people think that this refrigerator and creating ice was a bad idea. He called it manufactured ice, and he was telling the world that manufactured ice wasn't as safe for you as the ice that came out of a lake. So it was because he didn't want to be disrupted. In the end, he was.
So in the end, he didn't stop. So the only one that's going to ever stop these guys from changing the world is them.
Yeah, I think so.
Question?
Yeah. So you did a lot of startups, and you said that you guys started with the money in your pockets. One thing I was just wondering is how did you actually sort of maintain financial security, and how did you, I think you said you worked for NASA at one point, but how did you do all these things and do these startups and have the money to do it?
Yeah.
And get investors and that kind of stuff.
That's kind of the beauty of trying to do a startup when you're young, is you have way less like responsibility in ways. So I moved to California. I had a little bit of money saved up, and we figured out how to make money as quickly as possible. Like with NASA being our customer, we were just proposing to them nonstop, trying to get the right meetings so that we could get our foot in the door and get the right things happening, and it worked. At the same time, I had other jobs. I actually was, which is hard, but luckily I worked for another company called Moon Express, which was a space company building robots for the moon. So it wasn't that I was working at McDonald's and then going and doing this. So I was learning a lot, working for one startup, helping build it while I got to build my own. And I was very fortunate to be able to have that scenario, but at some point you have to leave that, and I had to. I got to the point where my startup would fail if I wasn't there. It's about taking risks. I mean, like everything I've ever done in my life is because all the good things are because I took a huge risk. When I went to Singularity University, it's really expensive to get in once you're accepted. And I had scholarships, but I still had to front some money, and it was like the majority of my savings. And it was what my parents helped me save up my whole life so I could buy a house. I called them. I was like, guys, you know that money for the house? I'm going to go spend it for this 10-week thing in Silicon Valley.
So how'd they react? Did they hang up or did they stay on the phone?
They trusted me, so it worked out well. But it's about taking risks and hoping it pays off.
How are you preventing yourself from being disrupted and made in space? Are you focused right now on 3D printers, or are you still looking past that?
We're always looking past it. In 2010, nobody was thinking that 3D printers would be disrupting the space industry, so we were already ahead. Now all that press and everything has definitely created competition, which is a good thing. But still, we're still ahead. We've been thinking about this longer than anyone, and we don't talk publicly about what the other things we're doing, because that would probably not work out well for us. But we're always working on the next thing, and it's important to we reinvest the money we're making into R&D rather than paying everybody really awesome salaries.
Are 3D printers restricted to a one certain material that you can make things out of, like plastic or something?
They're actually, so they're super versatile. The printer that we're building for NASA it builds plastic parts. It's kind of basic, but the technology itself ranges from aerospace grade metals like aluminum, titanium, to a variety of plastics. There's printers that print 128 different materials at once. It uses an inkjet technology, so it can just like your inkjet printer basically, and it can print. So you could have a solid plastic piece here that transitions into really flexible. Wow. Yeah, it's incredible stuff. And that company is every day they have a new material. It's it could be 130 at this point.
Hey, how did you find your mentors? As you went through, I heard mentors a lot.
Yeah.
You had some impressive folks on that list.
It's probably a lot about the whole taking risks and not being afraid to walk up to people. My one thing that I use a lot, it's probably once a week at least. I actually right now all the time is it's actually Peter Diamandis. He has a lot of good quotes, I guess, that I follow. But one of them is start at the top and work your way up. So anytime I need something, I go to as high up as possible. I mean, at Main Space, we're sending emails to people that shouldn't even answer our email, and then they do. And then we're next thing we know, we're on a plane to DC to a headquarter building to talk to somebody really important. So it's about sticking your neck out and asking for something. You ask for something, they'll help you.
Earlier you had a picture of the Stanford Taurus stuff. Have you ever thought of working with NASA or getting one of your groups to work with NASA on starting this project?
Absolutely. I mean, that's actually, when we first started, we were saying, At the very beginning, that was it. We were like, one day everything in space is built there. You're going to build giant things like colonies in space. But the thing is to build a business, there's not really a business model in building a space colony right now because it's very capital intensive. It's very far out. So you have to understand where you want to be, and maybe it's 20 years away, maybe it's 30, maybe it's really far away, and then create all those steps to get you there. And we have that planned out all the way to the point where you can build space colonies. And right now we're at this tiny little bottom step of let's bring manufacturing to space with a little 3D printer on the space station. And it's that's how you disrupt. That is the curve of disruption. People won't notice it. They won't notice it because it's really low on the radar. And we're going to be building that stuff, and then one day, all of a sudden, this will happen.
So Jason, maybe that's a good way to kind of end this part of the talk. If one day we're going to change the world, and what you've done is you started here at UCF,
yeah.
and you reminded us of that journey, thank you very much.
Oh, thank you. Thank you.